this video, Dume. This video is going to be on nature of matter. We are going to discuss various subtopics involved in nature of matter, including states of matter, kinetic particle theory of matter, and diffusion, just to name a few. Without any waste of time, let's get to the class objectives. Matter in terms of particle arrangement and movement, and changes of states of matter in terms of kinetic particle theory, and diffusion of particles in fluids, and dependence of rate of diffusion on molar mass, and diffusion of gases. We have three theories of matter, namely liquid, gas, and solids. And all of them basically have different arrangements and different movements. For gases, particles are further apart, and the movement is very random. Movement of a single particle cannot be predicted. For liquids, particles are close together, arranged in such a way that they're a little bit close together compared to gases, and their movements, they move in such a way that particles slide over each other. Some close particles will move, they will slide over each other. For solids, particles are tightly packed. Very neatly together. And the movements, they have tiny vibrations. At fixed points. And as we go on, I'm going to show you an illustration of the arrangement of particles. The kinetic particle theory of matter. You should all know that everything or anything that possesses space, which is matter, is made up of particles, and those particles that are always in motion. Particles are always the particles that make up matter are always in motion, and when the temperature of particles is increased, their movement increases, and when the temperature is decreased, the movement of particles also decreases. And from this, you should be able to explain the processes that are involved in change of states. Explaining them using the kinetic particle theory is one of the expected objectives of the BGCSE level chemistry. You should be able to know melting. What does melting entail? From solid to liquid, you should know that from solid state, particles are tightly packed together, and when you introduce temperature change, increase in temperature, the particles will begin to gain kinetic energy, and they'll start to vibrate quicker compared to in a solid state. And as they approach the melting point, when particles approach the melting point, they'll begin to move in a different sense compared to in a solid state. They will begin to slide over each other. Should also be able to explain freezing, boiling, and other states, condensation, evaporation, and sublimation. You should be able to explain all these processes using the kinetic particle theory of matter. For further information, you can contact us. You'll be able to explain the processes in much more detail compared to in the slides here. Diffusion, you expected to know diffusion in fluids. You should know what is diffusion. You should know that diffusion is movement of particles from an area of high concentration. Here we have more particles of gases. Here we have less particles of gases. You should be able to know that they move from high concentration to an area of low concentration until you reach a concentration gradient where the number of particles this side is equal to the number of particles this side. All particles are evenly distributed. This is what I talk about, a state of equilibrium, where number of particles this side is equal to the number of particles this side. And then you should know, what does diffusion depend on? They say here that the rate of diffusion depends heavily on the molecular mass of atoms. If the molecular mass of an atom is much larger, it will diffuse at a lower speed or a lower rate compared to particles that are smaller in molar mass. Example, for chlorine gas, chlorine gas will diffuse at a slower rate compared to hydrogen gas, because here the molecular mass of hydrogen is much smaller compared to the molecular mass of a chlorine gas. And you should also know that diffusion also depends on temperature. If the temperature is very, very high, then diffusion, the particles of a gas will diffuse a lot quicker compared to when the temperature is very low. When the temperature is high, particles gain kinetic energy and they start to move at a very, very rapid pace compared to particles that have less kinetic energy or less temperature. Here we have different processes that are involved in state of matter changes. From solid to liquid, we have melting. There's a point here, a very important point called melting point, or can be that is involved when there's a point where particles move from a solid state to a liquid state, and from a liquid state to a gaseous state we have boiling point. We have a very important point called BP. When that temperature is reached, that certain temperature, it's very specific depending on the substance that you're dealing with. Once you reach this point, particles will move from a liquid state to a gaseous state. They will begin to move in a gaseous manner, which is very random, and the particles will be further apart. And there are also other special processes that are involved. For example, when you skip from a solid to a gas, we have sublimation. When you skip from a gas to a solid, it's called deposition. And also there's a reverse of evaporation, condensing, and a reverse of liquid, which is freezing. For much more information, for further information on boiling point, melting point, and the various curves that are involved, the cooling curve, and other curves, you can contact us for further more information.